Okay, so I think we are ready to start. Today is the last lesson of data carpentry. During the first day, we show how to get some data in could be on a spreadsheet format. We can later export to CSV, comma separated values. We use the spreadsheet software to open the data and have a look at it. And also we use OpenRefine to refine, clean that data. Yesterday and the day before, we use R for plotting, for also cleaning the data, remove data that is not needed, like data that some fields are empty. And today what we will see is another way to get data and do queries about it. We will learn more about SQL, or there are two pronunciations, SQL, and also some people said SQL. So you can choose the one that you prefer. Personally, I don't know why I always use SQL. SQL is the thing that stands for structured query language, and the idea is through using queries, get the information that we want from the data set. If you remember yesterday, we were using some functions called filtering, um, mutating, arrange, etc., in order to get information from the data set, present that information maybe in a table, a plot, etc. So today we will do something similar. Why we are learning that? Because could be the case. Okay, if you can download the data into CSV, you can always use R, or also you can use SQL if you prefer to do so. But there are some cases that the data sets are already available through a database. So in that case, it's useful to know SQL. If we have time at the end of today's lesson, we will see how to use R to connect to a database, SQL database, and do queries through R. But yeah, we will see that later at the end of. So I'm talking about SQL. So this is one of the concepts that. And also you will see the. Let me maybe see if I share the notes. Or I've also forgot to say that this is today's lesson, and I will share. Let me see if share application screen should be data management. Okay, so this is today's lesson. We have seen what is SQL. And here there are some definitions. We are talking about why we are using databases. The thing is, when you use a database, it's very difficult to modify very difficult. I mean, you need to do it on purpose if you need to modify data. But normally, when you use a database, maybe at the beginning you need to create a database, define the tables that we will see that later. But most of the time, what you are doing is you are performing queries. You are asking questions to the database dataset in order to get answers on got some findings, and you can create some plots with the data that you get, and you can, if need, you can publish them on a paper or present results in a conference, etc. So there are several concepts that we have explained. What is SQL? That is the language that we will use to write the queries. Also, here is mentioned the relational database. We have a database is a set of tables, and the thing is these tables are most of the times are related each other, and we will see later that we can do we can perform queries asking data from several tables. Also, we have the concept of a database management system. The language that we use is SQL, but you can have several, or you will find, if you work with databases, several database management systems. We have, there are Sqlite, MySQL, PostgreSQL, Microsoft SQL, and others. I think Oracle used to have, yeah, Oracle is also a big one. Today we will learn more about Sqlite. Why? The advantage of Sqlite is like a small database management system. Small because it doesn't have the features that other uh, management systems like MySQL, Microsoft SQL, PostgreSQL, etc. have. The is small, and the advantage of that is that the database is saved in only in a file. You don't need a server to connect and do the queries. So the database would be only a file. The thing is, could be like other databases allow a lot of connections from a lot of users, but in our case, we will not need that. So that's why we are using this, and this is also a good starting point. Start with a small database management system like Sqlite. And the concept of the databases is the same that what we have learned in previous. We have a table that could be we have the observations are in rows. We have columns that we have each variable is related to a column. A column. Well, in the database, you will find that maybe you talk about fields that are the columns, and records are the rows. This is important, and we learned that in the first day that every row column combination contains a single atomic value. So it's not a good idea, or it's not recommended to have several values inside the same row column combination. Okay, so this is the introduction. Not sure if you have any questions regarding that. So the important concepts here are SQL, that this is the language that we will use for to perform queries on our database. Database is a set of tables if we talk about a relational database, these tables are mostly are related each other. We will see that later. And we will use SQLite. That you don't need a server. You only need a file to do all the queries that we want to do. Okay, so I think we are ready to start. So what I will share now is the software that is called DB browser for SQLite. Hope that the font is big enough. So what we will do now is we will create our database. We have several CSV file, comma separated values files, and we will open them and import them to our database. So what we will do is first we will you can see my, let me, okay, I will share again. Maybe is it working now? Mm, okay, maybe I will, rather than the app, I will share the the window. One moment. Uh, do you see the screen now? Oops. Uh, okay, okay. Okay, so yeah, seems that, yeah, now, okay, great. So this is the software that we will use today. Is called DB browser for Sqlite. And the first thing that we will do is to create our database. So we click here on new database, the button that is top left, and we go to desktop. Well, because I want to save it here the database, and I will call it data carpentry. I will save it, and well, here I can create a table, but I'm not interested on creating a table. So now here, the top, you will see the path where the database is saved. And what I will do now is I will import the tables. I will do one table, and you will do the rest. I will give you some time to do the. So the way of importing a table is if you click on File, then you click Import. You can import the database from a SQL file or a table from CSV file. In our case, we will import a table. And I will go to the folder that I have downloaded before. And I will start importing the table surveys. If I click in Open, you see the table name is surveys. You may find that this is not checked, the column names in first line, and you will see that you get field 1, field 2, field 3, etc. And the first entry will be the names. But if you click on here, in column names in first line, you will see that the fields get the names of the columns. Also, you can check that the table, this is the first rows. You check that more or less it looks okay. This is mainly because detects the field separator, there is a comma. Also, if you use characters, so you may want to use, you may find in the CSV file that they use quotation marks, the encoding, trim fields. So yeah, seems that the table is okay. So if when we click in OK, we see now that we have a table called surveys. And also here we have all of the fields of this table. What I can do is now I will need to I can edit because you see, for instance, the input length is a floating point number rather than text, and I can edit if I click on modify table, well, they ask me to save. Okay, I save changes, and I can check the name and the type. Record ID is integer, month, date, year, integer, plot ID, species ID is text, check is text, and the only changes that I need to do is here this is real, and the weight is real as well. This is another thing of in Sqlite that the types, if you see here, I have only a few. If I use MySQL or other database engine that is bigger, you will find that you have many other types. But for this, we don't need them, so this is enough. Okay, so if I click now in OK, I can see service. I can see that now the input length is real, the weight is real, and well, I see that yeah, the rest are integer, text are species ID and sex. So now the exercise is to do the same with the tables that are called plot and species. Please let me know when this is done, and we can continue. Cool. So what we can do is we can import tables together. Let's do that. So we need to repeat same steps that we did for surveys. We click in File, Import Table from CSV file. So I want to include the plot. Plots is easy because we have a plot ID and the plot type. Clicking OK. I will check if plot ID integer, plot type text. So fine, we don't need to modify anything. And the other one, import table from CSV file, species. So for a species, we have a species ID, genus, the species, and taxa. I click on OK. And also when I see the structure, I see that it's text. Yeah, so that's fine. Very important concept here when we work with databases. As you can see that we are during these 4 days we have used the same, let's say, similar same data set, but sorted in the different ways. And you see that here we have three tables. The idea here is not to repeat the same information inside our database. What that means, if you open, you will find this is for the table surveys. If you go to browse data, you can find here the contents. And you find that we have a column that this is a species ID, that is, for instance, NL. And if I go to the table species, let me, well, I can filter, I can write NL, and I get that the species ID is NL, and I get the genus, the species, taxa. I could include these three fields in the other table, but the problem is that in case that here I find a typo in the genus, or for some reason I need to update the taxa or the species or whatever, I I need to update this having in a separate table. I need to update just in this table, and that's it. And having in the other, having that information in this table, this information will be, well, rather than duplicated, will be repeated many times. And also the space that we are taking to store all of this information is way bigger. So that's why we're talking about not repeating information. So this is a very important step. And also not here you can see the relation between both tables. Both tables surveys and species are related by this column. A clear example of not to repeat information, imagine that you have a database of with people, and you have the address. And if you have another table that it could be like, I don't know, patients, if and one patient visited the hospital, let's say 10 times, and in the table visits, you include the address, imagine that that person changed the address. So you will find that you need to update the table 10 times rather than only updating the table called people. So that's the important thing here, not to repeat information between tables, because otherwise the information could be outdated. Don't know if that makes sense. Okay, so we have here the three tables. We can browse data using this interface. And we can filter, etc. But how can we do that using SQL? So this is the things that the language that we will start learning just now. So to select, well, to print the contents of a table, I need to say what I want to, the columns that they want to print, and also I want to say from which table I want to print them. So we will learn how to do that. So the syntax is select. If I want to select all fields or columns, I write star. Select everything, select star. From the table will be surveys. You remember that in R we don't finish, we don't need to write a semicolon. Here is we need to do so to execute SQL. So SQL finish the sentence with a semicolon. So when we execute that, think it's Control Enter. Yes. You see at the bottom that well, the execution finished without errors, and also tells you what the time that it takes to retrieve the whole table. That was 146 milliseconds. This is you may find big, but this is a very small table. I have seen tables of megabytes, gigabytes. So you will find that some operations will take way longer than that. But well, this small data set, that's fine. Things regarding the syntax, there are some keywords that are select from. Normally, I write them in capital letters, and the name of the table, name of the column, I write them in small letters. And also you can write the sentence in one line, but to give, well, this is a small one, but you will see that we will have bigger ones. I may want to use several lines and have each line starting with a keyword. So here I select everything from surveys, but also I can select column day, month, and year. So if I execute that, you will see that I get these three columns, and I get all of the entries from the table. Also, you may remember that in R we have the head function. So also I can use the keyword limit, and I can say how many rows or how many entries do I want. This is just in case that you want to have a more view of the table, just you're interested, let's say, in the first 10 rows. So if you execute that, you see that the result are 10 rows. So this is regarding, these are the queries, can limit the results. Also, you can get, because imagine that you are interested in the how many years how many distinct years has the table survey. So well, the question could be, okay, what is the period? How many years the table contains? So you can do that if you can modify the query, and you can say select distinct. So here we have the help. So is this keyword, select a distinct year from surveys. Well, I will remove the limit. So if I execute that, I get the years I have 77, 78. I have all of them until 2002. So I can see here that they have 26 different years. I can use the same with any other column. For instance, I can use species ID, select distinct species ID from surveys, and you will find that we have a total of 49 species ID. Also, yesterday we learned how to use mutate to have calculated columns, because the weight here is in grams, but what if we want the weight in kilograms? So we can do the same as well with the SQL. So we can, for instance, get the plot ID, species ID, sex, and the weight. Can be divided by 1000, for instance. If we execute that, well, here we have a null values, but you see that the weight divided by 1000, you get this. We will, okay, we will learn another. In, Yesterday we also learned that we can filter data. We can say, okay, I want to get rid of the null, well, the NA values that SQL, the nomenclature is null. I want to get rid of the null values. So one thing that I can use is the syntax where. So where I can write the name of the column, weight, and I can say is not null. So if I execute that, you will see that now the weight is null values are removed. Also, to double check if the weight is well calculated, we can include the column weight. And you see that the weight in grams is 40, the weight in kilograms is 0.04. You may want to have like both columns, one with the weight, one with the weight in grams and the weight in kilograms. So you can do something like that. Okay, so a very small exercise. Is write a query that returns the year, month, day, species ID, and the weight rather than in grams, in milligrams. Let me know when you're done with the exercise and we can see the solution and continue. Cool. So let's see the solution. Okay, let's delete everything. So the exercise is write a query that returns the year. So it's select year, month, day, species ID, and the weight in milligrams. So we need to multiply that by 1000. From surveys, I will include in order to get rid of where weight is not null. So here I get the result in milligrams, species ID, year, month, and day. Okay, so let's continue. So for filtering, we have done that in this exercise, we have filtered the null values, but also I can filter by, for instance, the species ID. I can say, you see that I'm getting the weight in milligrams for all the species, but also I can say where weight is not null and species ID is equal DM, for instance. If I execute that, you see that the column species ID the contents are all DM. Also, I can filter because I get from year 77. Imagine that you want to do, okay, let's select everything from surveys where year is greater than 2000. So you see that all years are, well, we have a 2001, 2002, and 2002. There are 2 years on the table that are greater than 2000. We want greater than or equal. We get the year 2000 as well. So this is what we can have. So where is where we put the filters. Also, we can combine the filters with and with or. Imagine we want the year equal 2000 or a year equal 2002. So we get the year 2000 and 2002. You need to be careful with when you execute this. Well, in the documentation is they recommend to use brackets to make this because also inside the brackets you can use this or and. So you need to be careful because maybe if you use or, you can get you don't do any filtering, or you filter the whole table because the condition is false for all the fields. So it's always important to double check that the filters works as intended and give the results that we want. Okay, there is another exercise. I will copy and paste this here. So it's produce a table listing the data for all individuals in plot 1 that weighted more than 75 grams, telling us the date, species ID code, and the weight in kilograms. Okay, thanks. Could you still see my screen? Okay. Okay, thank you. So I will. Okay, so let's solve the exercise. Produce a table listing the data for all the individuals in plot 1. Okay, so what we will do is we will select everything. Later we can see the fields that are needed. From the table surveys. The important thing here are the filters that we will use. This said that individuals that are in plot 1, so we need to write where plot is equal 1. Okay, we will use brackets to make things safer. And the weight is greater than 75 the weight more than 75 grams. Okay. So we are interested in the date. So it would be can use day, month, year, or year, month, day. Species ID code. and the weight in kilograms. So we need to divide by, oh, true, plot ID, thank you. Day, month, year, species ID, and weight divided 1000 from surveys where. Okay, so this will be the result. Another thing that is explained later in the documentation, but well, I can explain it now, that the weight divided by 1000, if I want, I can modify the name of the column, and I can say weight kg. That's a good question. The weight, because what I'm modifying here is how I present the results. So what I do is the weight, I divide the weight by 1000. But here, when I filter, I get the weight that is saved on the table. The weight that is saved on the table is saved in grams. So I need to filter using a 75, because the modifications that I'm doing here is when I present the data. I'm not modifying any of the data on the table. That's why I'm using 75. That will be okay. Let's do this. Let's execute this, and we see that we get 261 rows returned in 10 milliseconds, and I get this. If in okay, there is a question that is that this result is not shown in. There are no digits after the comma. I think check the go to database structure and check the type of the weight should be real rather than integer, or so here could be the problem, the type of the column. Also, because I'm using here this this is called an alias. Here I can either use weight, or if you want to use the weight in kilograms, you can do that. Well, let's see first if that works. So it will be 0.75. So we get 2,261. Let's see if that works. Yeah, it works. Because now in this comparison, I'm comparing with this rather than with the weight itself. So that's why alias is we can use either to change the name of the column, but also if we want to use this afterwards, we can use this alias. Hope that makes sense. If there are any questions, please let me know. If not, we can continue. Okay. We have seen here in filtering. I will leave. Okay, let's make this query maybe easier. Day, month, year, species ID. Where the species ID is equal DM, for instance. So if I execute that, I get of the species ID, there are DM. Or I can get the species ID that are equal to DS. or species ID that are equal to don't know what else do we have, check DO, for instance. So if we execute that, I get all the species ID that are DM, DS, or DO. This is a little bit, as you may find, a little bit long because I need to enumerate species ID DM, DS, DO. So there is an easier way to write that. So the easier way, I will copy and paste, and you can see the differences, is using in. So if we use in, we can say where species ID is in, and the values that we want, that is DM, DS, or DO. So if we execute the second one, I can get the same results. And the query is more readable because you see a species ID in, DM, DS, DO, and you can get here, let's see, you can work with the years that are 2000, 2002, 1977, all of these things. Also important, one point that I haven't explained is regarding comments. We can add a comment adding two hyphens at the beginning, or two. So we can say query to get the date and species ID. For instance, you can also do other comments. This will we use for the study done by the university, for instance. So you can add comments using two hyphens. Also, we can use we can short. So we will. Yesterday we seen with the R what using if we can use a range to sort the results, but also here we can do the same. So we can do select everything from a species. If I play, you see that we get all of these. And we can say order by taxa, for instance. So if I execute that, well, you see that the taxa is not sorted. If I run that, we see at the beginning, we see all birds, rabbit, reptile, and rodent. By default, this is using a ascendant order, but we can use descendant, and we get instead from A to Z, we get the other way around. we can also order by different columns. So we can have a genus ascendant, taxa descendant, for instance, and I can get something like that. Um, okay, I have let's do two more exercises. Okay, where are these? Here. The second one is here. Exactly. So in this case, first is there is a question that said that if the ordering will be first on genus and then taxa. Yeah, respect the order. First is sort by genus in ascendant way, and then by taxa in descendant way. We add this for more clarity, but we can get rid of this because by default use the ascendant way. In case that you want to sort by date, you need to read like order by year, month, day, and then we will start first with the year, then with month, and then with the day. So it's like from left to right is order or sorted. For the second exercise, I haven't explained the function round. I will write the syntax in the chat. So that's the function. Is x is the number, and is the first parameter. The second one is the number of decimal places. Cool. So let's solve this together. I will copy and paste this here. So okay, write a query that returns year, species ID, and weight in kilograms. So it's select year, species ID, weight in kilograms. So it's divided by 1000 from surveys. Sort by the largest weights at the top. So what does order by weight desk. So yeah, have a year, species ID, and the weight in kilograms. Sort by from maximum to minimum. This will be the first one. Second one will be, let me make this using the service table, write a query to display the three date fields. Okay, so we have select year, month, day, species ID, the weight in kilograms. This is rounded, so we need to use the function round. And what if you see the pop-up menu tells us the returns a floating point value x rounded to a y digits to the right. From surveys where the individuals, so year is 1999, and sort order thereby species ID. Cool. So it should be something like that. Okay, there are some species that are null and wrong. If we want, we can get rid of and the weight is not null. Species ID, in case that we don't want to. So you see that we get all dates are from 1999, and we get the species ID and the weight in kilograms rounded in 2. Also, a comment that I have seen other people that use, but well, it's not that these keywords are in small letters and the fields are in capital letters, so they use the other way around. Okay, so the important thing is to be consistent and to use the same structure or use the same pattern along the document. Like if you write and you save all of these queries on a script, like follow the same policy or follow the same structure. Don't use here capital letters. In the next query, you use different style. Okay, this is the word that they wanted to find, the style. So follow the same style for all queries. Okay, there is a comment in the chat saying that the round function does not exist. I don't know if that's maybe because of the version of the software. This function is okay. Well, okay, so that's interesting that you. Not sure if it's the version of the software. Do you use Windows, Mac, Linux? In theory, Windows. Okay, so that's more. I'm using Windows. I'm using the version that is not installed. Maybe it's don't know. We can see that in the. Yeah, so must be the same that I'm. Okay, the same that I'm using. Or maybe something, I don't know if it's something with the syntax or. Oh, okay, it's interesting. But what is okay, but well, the thing is, I, I can, I can write that in, okay, yeah, true. I forgot to explain that. SQL doesn't matter if you use capital letters or not, so you can use round. But yeah, it could be the case that maybe for some reason the function is not available. But yeah, you see, yeah, the suggestion is around. Yeah, you can use in small letter. It's okay. But it said that it throws an error. Okay. With the okay. Yeah, it work. You see, it works the same now. Rather than in capital letters, it's in small letters. So doesn't matter that if it's capital letters or not. What is weird that is the function is different. I think maybe it's the argument. Have you checked that the weight in your tables are real rather than integer? Could be that. And that's why, because if I, let's say, if I want to use a year, no, in theory this should work. Hmm. Okay, we can have a look later, but yeah, should in theory function row should work, but so could be an issue. Yeah, we can. Yeah, we can have a look later if you want during the break or and see what happens. Okay, so next thing is because another yesterday we could count the number of rows that we have in our data set. So we can do the same with SQL, counting the number of rows that we have in our table. So we can do select count. Again, this like suggesting a small letter, so it's up to you. It doesn't matter if it's capital or not. The thing you need to be like consistent with the notation. Everything, oops, from surveys. So you see that the count is the number of rows is 35,549. Also, you can use the function count. You can use the function sum of weight, for instance, and you can do the summatory of all of the weights that you have on the table. That, not sure if that number is a very significant, important, but well, you can do that. And what else you can do? Yeah, you can do the, maybe it's more important. You can do the maximum here, maximum weight, that is 280 grams. Okay, I will see that there are two different rounds. Weird, but well, that's okay. So yeah, one thing that is always learning. So there are several functions. We can use count. You can use sum. You can use also the maximum, minimum, average is AVG. But this is the average with the respect of the whole table. What if we want the count and average by species ID? So we can do select the species ID, count the average from surveys, no, group by species ID. So if I execute that, well, I get nulls here because some of the weights are null, and I guess that, yeah, the average is not working. So for instance, for the species, for DM, the count is more than 10,000, and the average weight is 43.50. I think I can filter where weight. And because this is a very long number, and maybe we want to round this. Now you get for each species ID, you get the count, and you get the average weight. You can also get, if you want, the maximum, minimum. And for instance, with a simple query, you can get this table that might be useful to know the weight of all of the species that we have in our table. Also, I noticed that I've done the exercise is similar to this. The exercise that is in the documentation also wants the weight should be between 5 and 10. So you can do on the weight larger or equal than 5. And weight smaller or equal than 10. They recommend to use brackets. So let's do that. So you see that now we have a smaller rows and the maximum is 10 and the minimum could be 5, 10, 6. Or it's evident the species ID, the count is 1, so we have the average, maximum and minimum is 10. Yeah, I was having a look at why we will have, because the count is only 1. Also, you may remember yesterday that if the count was smaller, this was a filter when we got the. So if you want, you can also do that. If a count is smaller than 5 or 10, you don't care. For instance, this one maybe are more significant for your study, but yeah, having a small count is not. Okay, I see that we are now in break time. So we will have a 30-minute break. We'll be back at 11:30, and we will continue learning more about SQL. So have a nice break and see you 11:30. Hello everyone, welcome back. So now we are. I hope that you had a nice break. Now, if you find the schedule, we have some minutes. We will not spend 15 minutes. Will be like I think we will, in order to finish earlier, we can reduce that to 5 minutes. Uh, we have two surveys. We have the praise course feedback and the post workshop survey. The second one is a little bit longer. If you remember, the first day we did the pre-workshop survey, so it is important if you complete the post-workshop survey. This is the results are received by the Carpentries, and they analyze the results, and they can do some amendment, some changes to the workshop. But most important here is the praise course feedback. As you can see, these courses are delivered for free, and they are funded by Praise and ARCHER2. And the thing is that we need to report some feedback to them in order to justify that these courses have been attended and they are going on. So I would appreciate if you can. I will paste the link in the chat. If you can fill that, only a few questions are mandatory. The rest of the questions are optional. And if you can complete also this afternoon or anytime this this second one goes to the Carpentries. So if you can complete them, and we can start in the 5 minutes, if that's okay. I will move this here. Okay, so I think we can continue with the lesson. So we were okay. Let me share my share files application. Please, could you confirm if you can see my screen, and also to see if you are around and you are still not on the break or filling in the survey. Thanks. So okay, this is the last exercise that well, exercise the last example that we have seen, that we can get the average, maximum, minimum weight, and for each species ID. And also we have here the count, that we see that we have counts of 1, 5 that maybe are not very relevant. Another thing that we can do here is we can filter when the filters that we apply in where are filters of the columns that we have, but also we can apply filters of the grouping operations, that we can apply a filter to the count, max, minimum, but we need to use having is the new keyword that we will learn. So here I need to use the alias count. I can use a count as occurrences. Yeah, it's like a occurrences, and I can say having occurrences greater than 10, for instance. If I execute that, what is well, now we have if the syntax is not, or if something is not correct, we get an error. And the error here is that there is no column occurrences. I always have this problem with this word because it's two C's rather than one. Okay, so now it works. And now the table looks well, much better. We don't have a results that the occurrences is only 1 or 5. So we do this. We can do this filtering using using having. Okay, so also we can, if we want, we can also sort in case that we are interested in. Can use order by occurrences. And we see that the occurrences are from minimum to maximum. So that's the thing, that we can do all of these things using SQL. Also, this is an interesting, we can create, okay, I will close the, seems that, close the window, so a little bit noisy outside. We can create a view. What is a view? A view is we have a table with all of the information, but we are only interested in part of that table. So we can execute a query and have a view. A view is like a subset of the table that we have got using a query. This could be used for simplicity to do further queries and also for privacy reasons. Imagine that you have a table for people and you have the address, you have the telephone, you have age, you have a lot of information that you don't want that maybe other people access, other users of the database access that table. So you can, I think this is not possible to do this with the SQ, with this SQLite because all the information is in a file. But when you use a server, you can you can grant users um, permissions to access tables, or you can grant access to a view rather than a table. So here, well, this is like more complex. Here for we will use views more for simplicity in case that we want to get the results for a project for a given year. We can create a view. Okay, so how we can create a view? First, we need to choose what we want to get in terms of in the view. So once that we are happy with the query, we can save that query as a view. So the sample that is in the documentation is we're interested in getting the occurrences, no, the getting the observations for summer 2020. So we can create a view having only these observations. My recommendation, first step is to write the query. So the query will be select everything from surveys where a year is equal to 1000 and the month should be greater than 4. So we will consider May as summer. Maybe, yeah, it's not a very no, okay, let's start with June. And the month should be less than 10. So we will get here, actually, rather than summer, we will get here the months June, July, August, and September. So we will have 4 months in our table. Let's print that to see if that's okay. So you see that the month we get June, July, August, September. I can do that because the table is pretty small. When we have a huge table, this, you cannot browse the table like that. And in our new query, we have a 719 rows. So if I want to work with this part of the table, what I can do is I can save it as a view. How can I do that? I need to create a view, the name of the view that it will be summer underscore 2000 as, and well, I get select everything from server. So this is the important bit here. So I create a view, the name of the view, and then as, and the rest of the query. So if I execute that, well, we get the query executed successfully. And when I go to the database structure, I see that I get a view that is summer 2000, where this is the SQL syntax that we use to create the view. So now I could use the view to perform queries. For instance, select distinct species ID from summer 2000. I can get the species ID. Also, I can get the count. Well, because if I write a star, I get the count of the whole table, but the count of a species ID. Okay. The problem here is the distinct. No, group. Okay, forgot the group by species ID. Okay, that was the when you use a count by a given column, you need to first group by, do the group by. So we see that for each species ID, I get the count. So we can use the view as a table. So also that simplifies a lot of things and makes queries more readable. And also for some reason, if you want to give a researcher, okay, work with this table, only with this table, you can grant access to that table. But this is using, as I said, other database engines. What else? Okay, I think this is. So now what we will learn is how to play with the joins, how to play with the two tables. The way of doing that, we can, if I do select everything from surveys, I get this table and I get the species ID and L, DM, but to make the table or to present results, imagine that we want to get the table from the results for a paper or for a blog post or whatever. We would like to give the rather than the species ID to give the proper name of the. So the issue here, well, not an issue, but the here that the full names are in the table species. So we will need to combine both tables. The way of doing that is joining both tables. How can we join that? So there are several ways to join a table. The one that we will use here is, well, I will explain a few of them, is select everything from surveys, and then I use join species on. I need to specify the when I join the tables, I need to specify the columns that are common, the column that is common in both tables. That you will find later that this is we are talking about this is the foreign key of the. Okay, I will explain this later. So now when the syntax that we need to use is we need to specify the name of the table, that is surveys dot, and now the name of the column that we want to, that is a species ID, must be equal to a species that is the name of the table, and a species ID, that is the name of the column. So if we execute that, you see that now we get both tables together. So we get a species ID here, and also we get next we get the genus, species, and taxa. And when I do the selection, I can do a select here. When I combine both tables, is recommended to use the name of the table, surveys.day, surveys.month, for instance, surveys.year. And now I can use species dot genus, species dot let me check the names of the species. It's confusing that I have the same names. So I can get the name of the year, and rather than the species ID, I can get a genus and species. So to join both tables, I can use that. Another syntax that I can use is the following one, because the advantage that I have here is that both tables have the same name, the same column name. So rather than using this, I can remove that. I can say join species using species ID, and it's shorter. So if I execute that, I get the same result. So in that case, I can combine both tables. That is a exercise. Let me okay, what exercise we can do? Yeah, well, okay, let's do this one. So write a query that returns the genus, species name, and the weight of each individual captured on the site. Actually, the query is pretty similar that the one that we have done, but we are getting the weight rather than the date of the observation. Please let me know when you're done with the exercise. Cool, so I think, we can solve the exercise together. I will copy the exercise here on the double, okay. Write a query that returns a genus, species name, and the weight of every individual. So it's a survey's weight capture on this side. So if I execute that, well, we get that a lot of weights are null. I can also filter where weight it is not null. So you get genus, species, and the weight. All of these. So that's the thing, because a genus and a species are in the table species, and the weight is in the table surveys, you will need to join tables. One thing that has been is important when we do the join, we do the join in the content of the column species ID in table surveys must match the contents of the column species ID on table species. Let me just select everything from surveys. So this is the join on both tables. And here you see that the species ID, the column appears only once, because we are using this. You are using this. If you remember, in the previous example, species ID was twice that column. The thing is, what happens if there is no match? For instance, in surveys table, I have a species ID that doesn't exist on the species table. When you do the join, this is left that, and this is because we are doing, when you use join, is implicit is called inner join. So you need to always find a match on the species table. In case that you don't want to do that, you can use left join. What that means, that if in surveys, if we have a species ID that doesn't exist in the species table, the rest of the fields will be null. So genus, species, and taxa will be null, because there is no match with the. Not sure if that makes sense. It's a little bit complicated, but also to let you know that it could happen that you want to, for some reason, there is a species ID that is not contained in the species table, and you want to spot that. So you may want to do a left join rather than an inner join. That would be like that. But because the join by default is inner join, we don't include that. So this is regarding joins. What else? Okay, before, there are two more things. We will see two functions, and then if you are interested, we can see how to use R and SQL at the same time. Or better said, how can we use SQL in R? So the two functions that I would like to explain before we move on are the call coalescence and null if. And the sample is the following. We can do select species ID and sex from surveys. If we execute that, we see that we get M, F, and also we get null values. If we use the function coalescence, we can change null with a value that we want. So we can use coalescence I can specify that if the value of sex is a null, I change it with U. So now if I execute the query, you will see that this value rather than null is what if we have this function and also we have the other way around. Imagine that for some reason you want to let's say change M male, and you want to change that with the null. So you can do null if sex is M. So you see that if it's a M is a null, and if it's a female is still you can do that with the for instance with the plot ID or with the so this function you might want will be needed to use that for some reason. Okay, so this is regarding the SQL syntax. Do you have any questions about anything that we have seen of SQL? So if there are no questions, my suggestion is we can see how we can use SQL and R. I can give you an example, and also at the end I have more exercises if you want to play around with SQL. What do you prefer? Shall we see how to use SQL and then continue with exercises? Is that okay for you? Okay, so we'll see an example. Okay, so I will stop sharing. Okay, so what I need to do is I will need to open RStudio here. And I will share my screen in a moment. So there are the full documentation of what we will see now is here. But now what we will see is like a tiny example just to let you know how it works to. So let me make this smaller. Okay, so for if we want to use databases on R, we need to use these two packages that you can install the packages using that syntax. Install packages, and you select these two. In my case, are already installed, so I guess that I will get mm, okay, they download the, but yeah, were already installed, but well, anyway. And I need to download this. Okay, what I will do, maybe I will copy, but will be for you easier. I will copy that in a shared document. Carpentry chat. Okay, the shared document is here. So I copy that fragment of. So okay, we have installed these two packages, and now I need to download the database that is here, and I will download it to data row. And the database is called portal mammals Sqlite mode right binary. And well, this is what you need to download the file. So when you do that, you download the file, and if you go to data row, you will find that the Sqlite database is there. Now we need to load library, these two libraries. And what the first step is I need to connect to that database. So I need to connect R or instance with the database in order to oops. So what I will do is the variable mammals would be the connection, the database connection. So I mean the connection will be, we will do the connection to a file that is in our laptop. So you see what the syntax is this one that we are using Sqlite, and here I specify the address where my file is there. So if I execute that, you see that now I have in our memory, I have a Sqlite connection that is called mammals. Also, I can get information with that connection using this function. If I execute that, you see where this okay, because yeah, this is where the file lives, and also I see the tables that I have. I have a table plots, species, and surveys, and also source is Sqlite, and I get also the version of the file. And what I can do, I can execute this connection, mammals. I can execute this select the year species idea plot from service. So I can execute this SQL query using the function table. So if I execute that, you see that the source is SQL, and I get this output. So we can using R, we can execute SQL queries. In case that you want to use what we learned yesterday, rather than use SQL syntax, you can get the table surveys and save it as a data frame. So using the function TBL table, you connect to Mamas, that is the database, and you get the table surveys, and you save it in a variable. So you execute that, and you get, well, the thing is rather than getting you don't get the data frame, you get like a connection of to that table. But doesn't matter because you can, using the syntax that we learned yesterday, you can select the year, species ID, and plot ID from surveys using the pipe, so you may remember. So if we execute that, you see again that the source is SQL, but rather than using SQL syntax, you use the way that we used yesterday. And also, you can do, just to demonstrate that you can write another pipe, and you can do a filter plot ID equal 3. Okay, again, sorry, it's double equal. And now all plot ID is equal 3. If you want to do this with the SQL, where plot ID is equal 3. And you execute that. So that's the way of using, in case that you want to use R, or for instance, you get the result, and then you can plot the result. And doesn't matter if your results are in a CSV file or a SQL database, you can access them a different way, but the features and functionalities is similar. So you have just to repeat, you download the database, you create the connection. Okay, you install the libraries that are needed, and once that you have the connection, you can perform queries.